Dear students, now let us do the experiment to learn the steady state characteristics of SCR. The full form of SCR is silicon controlled rectifier. The aim of experiment is to study the steady state characteristics of SCR and to find the parameter, that means the latching and holding current of SCR. The required apparatus are as follows: SCR with TYN612 type 1 number, voltmeter 0 to 30 volt, moving coil type 1 meter, ammeter 0 to 50 milliamps, moving coil type 2 number, and DC regulated power supply. We need two power supplies for this experiment. We take both power supplies with a range of 0 to 30 volt, 2 amps rating. This is the circuit diagram for this experiment. SCR has three terminals named as anode, cathode and gate. The gate current is supplied through a gate cathode variable DC power supply. Anode current is supplied through anode cathode variable DC power supply. To measure the gate current, one ammeter is connected in gate terminal, and to measure anode current, one ammeter is connected with anode terminal. In order to measure anode cathode voltage, a voltmeter is connected across anode cathode terminal. With this circuit, current limiting resistors are connected to protect the SCR. This is the tabulation details for this experiment. We have to take two sets of readings for this different values of gate current. By keeping gate current fixed at one level, the anode cathode voltage to be varied, and correspondingly the anode current should be known. These are all the required precautions for this experiment. Before switching on this circuit, ensure that gate cathode and anode cathode voltages are at minimum position. This is the model graph for IV characteristics of SCR. The graph is drawn between anode cathode voltage and anode current. It can be observed from the graph that till forward breakover voltage, SCR is not turned on. Only the leakage current is flowing through it. Once anode cathode voltage reached above the forward breakover voltage, SCR starts to conduct and sudden increase in the anode current. Correspondingly, the voltage across anode cathode is reduced. This characteristics is drawn for different gate current. This is the gate used to do the experiment to find VI characteristics of SCR. This is DC regulated power supply. It has two controls, that means voltage and current controls. Both voltage and current controls are having coarse and fine adjustment knobs. Before doing the experiment, current knobs should be in maximum position and voltage knobs should be in minimum position. There are three connecting terminals, namely positive, red color, negative, black color, and ground. It is green color. Usually, positive and negative will be connected to energize the circuit. The LED indicator will show the voltage and current level in this circuit. It is the moving coil ammeter used to measure gate current. It can be connected between the terminals 0 to 50 milliamps. Since its scale is in 100 milliamps range, the actual value can calculated from the measured value by dividing by 2. It is the moving coil voltmeter used to measure anode cathode voltage. It can be connected between the terminals 0 to 30 volt. Since scale is in 15 volt range, the actual value should be multiplied by 2 from the measured value. It is the moving coil ammeter used to measure anode current. The terminals can be connected between 0 to 100 milliamps. Since its scale is in 100 milliamps range, the actual value and measured value will be same. These are all the instruments to be used to conduct the experiment. One SCR circuit kit, two DC regulated power supply, one moving coil voltmeter, two moving coil ammeters, and connecting wires as per the requirement. Now we have to do the connections. Okay, let's first connect the regulated power supply to the gate circuit. So connect positive to the gate and then negative to the cathode terminal. Then next, in order to measure the gate cathode current, we have to connect ammeter in series with that circuit, plus with that positive terminal, and the negative of that ammeter will be with gate terminal. Then in order to measure voltage drop across SCR, we have to connect a voltmeter 0 to 30 volt range. Next, we have to connect a regulated power supply for anode cathode circuit. Okay, so positive terminal will be connected to the anode and the negative terminal should be connected to the cathode. Now in order to measure anode current, okay, we have to connect ammeter. Okay, anode terminal will be connected with that ammeter of 0 to 100 milliamps. Now this is the connection setup for the SCR characteristics. Now before switch on the circuit, we have to ensure that the voltage knob at the minimum position and the current knob at the maximum position. Okay, then you have to switch on both RPS. Then we have to set the gate current. Okay, in this type of thyristor, we have to set gate current as 5 milliamps. So vary the gate cathode voltage and make it uh, to flow 5 milliamps. Then after setting to 5 milliamps, okay, now adjust that anode cathode voltage. Okay, if you gradually increase the voltage till conduction, there will not be any current. Okay, so anode cathode voltage increase. Once thyristor starts to conduct, voltage will be dropped and current value will increase suddenly. You can observe this. From the observation, we came to know that for a fixed gate current, when increasing anode cathode voltage, okay, till a certain voltage level, okay, there is no conduction, or otherwise only the leakage current will flow through that anode cathode circuit. So once the voltage level reaches to forward breakover voltage, thyristor starts conducting. Okay, then voltage drop across thyristor is suddenly reduced. Correspondingly, the current value will increase. So this is the tabular column. It will show for two different gate current. Okay, this is for your reference. This is the characteristics of SCR. Okay, if you observe from this graph, uh, VBO is nothing but forward breakover voltage. So till then, forward breakover voltage, there will be small leakage current. Okay, once voltage reaches to forward breakover voltage, thyristor will start current. The amount of current required to turn on the thyristor is called latching current. That is the minimum current required to turn on the thyristor. Then in order to turn off the thyristor, we have to reduce the voltage, anode cathode voltage. The minimum current to keep the thyristor in on position is called holding current. Okay, always latching current should be greater than the holding current. If you observe this graph, you can easily understand that. This is the graph drawn between anode voltage and anode current. You cannot exactly draw like ideal characteristics of SCR. It will become a straight line. In that, you can observe from this experiment, the latching current is 11 milliamps and the holding current is 1 milliamps. This is for your reference. That's all about the SCR characteristics. Further, if you have any doubt, contact us. Okay. We will explain with more